Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of exact equations illustrated through this example. Hopefully I've created these problems to where g of x or g of y is not going to be 0. Let's look at it in action. We need to take the derivative of m with respect to x. And normally m does come first, but don't let them trick you. You see how this is dx, m is usually attached to y. So this right here is your m of xy. So here, if I derive that with respect to x, I'm going to get a 2xy e to the x squared plus y squared. And I want to know, does that equal the derivative of n with respect to y? So that would be, again, 2xy e to the x squared plus y squared, and the derivative of the 1 here is going to be 0. So we can erase that question mark and replace it with a check mark. They are exact. So integrate the first one or the second one with respect to x or y, depending on which one you do. Actually, no parentheses needed. So if I integrate, it's going to be two separate problems. The integral of the first one is going to be a u sub. If you let u equal the exponent, then the derivative of that with respect to x would be 2x, multiply both sides, and solve for dx. Didn't do anything with that x, it sticks around for the ride. Your x squared plus y squared is the exponent of u, so the same thing of e, so the same thing happens to your u. And then du over 2x is what replaces your dx. So then you physically can see these x's canceling out. Bring out the 1/2. The integral of e to the u is just e to the u, so we have 1/2 e to the u, which then becomes 1/2 e to the x squared plus y squared. So now we integrate the 1, and the integral of any constant is always that constant times a variable to the first power, so that's going to be plus x. And since we integrated with respect to x, we put a plus g of y here. Always the opposite variable. Equals constant. Derive this with respect to y now. You're going to get the y e to the x squared y squared plus g prime of y. The 2's cancel from the derivative. Remember, the derivative of e to the something is derive that something and then rewrite your exponential function. So in this case, we're deriving with respect to y, so x goes to 0, then you get the 2y, 2's cancel. And this is what you get when you're done. Oop, this should be a 0, sorry. Derivative of a constant is 0. So now what you do is you set this equal to the other one that you did not integrate to see if there's a g y prime. And if I did it correctly, hopefully there will be. Which one did we integrate? We integrated with respect to x. So we need m, and that's going to be that plus 1. Good. So y e to the x squared plus y squared plus 1. So you can see that these cancel, and therefore g prime of y must be equal to 1. We integrate both sides, and we're doing dy here, and dy integrates into just y. So we plug that back into here to get our general solution. y that replaces the gy equals c. All right, so practice, practice, practice. I've given you enough examples definitely to get you going on exact equations. The next concept will be that you'll try all your other methods of substitution, but really whatever, and it doesn't work, and you try exact and that still doesn't work. But since you know the other methods didn't work, you might try the integrating factor for exact equations, which is a whole separate concept that we'll have a concept video and several example videos associated with that as well. Okay? For now, just practice these. You'll see they're not too bad. Thank you and have a nice day.